So we'll start. Thank you guys for all coming to learn Python. Hope you're excited to learn Python. We started, what we decided to start was sort of, why you should learn Python. Because you're all here, which means that you want to learn Python, but maybe you're not that interested, right? You're just coming to sort of see what this is. You should really continue to learn Python. And Python's a great language to start with because it's really easy to learn. I know you're not thinking about jobs right now. Some of you are probably, the juniors are getting bombarded about college. And I know it's really kind of nerve-wracking already just to think about college, but you are eventually going to have to get a job after college. I know it's a hard reality, but Python actually has a 19% year-on-year job demand growth, which means that every year the number of jobs that requires, or that at least asks for Python grows by 19%. So that's something that will definitely help you as far as that goes. So companies like Google, Yahoo, Disney, Nokia, and IBM all use Python. Now, some of you might be thinking, well, those are all software companies. Obviously, they use Python, but I'm not necessarily going to be a software engineer. Why should I still need to learn Python? Well, if you're in marketing, you might work for one of those companies. HR, management, even if you're just managing a project that uses software, understanding the software goes a long way. So I hope we've sold you, but if not, this might get you. Once you know how to program, you can do that.
Wow.
Yeah, that's pretty impressive, right? So we're going to go ahead and talk about, so how many of you guys have your own computers with you right now? None of you? Okay. A few of you. All right, so we'll go ahead and skip this then. We'll put this up on the website later, so once you're back at home and you have your own computers, just follow these steps. It should be pretty straightforward. And where it says await further instructions, just go ahead and start typing your code. This is basically Atom is the text editor we're using. Where it's like the Microsoft Word of writing code. Think of it that way, and that's what this is. So do that. So the first program we're going to work on is called Hello World program. Now. So do I have any guesses about what that might do?
Prints all the world on the screen.
There you go. Yeah. So what we can do is we can come here to. So if you're on Windows, this is how you're gonna open up Python. If you're on Mac, you just go to Terminal. I don't know how many of you have ever used Terminal, but we're gonna come to Python. And we're going to go to the one that says Python command line. We're going to make that bigger screen. No. Okay. So what we're going to do is you can type in code right here. So we're going to type in print hello world. And as you're going to see, it just on the next line, it prints out hello world. So that's cool. That's fun. You all know your first program now. Congratulations. All right. So there's print hello world. Now the next thing we're going to talk about are variables. And so Mark, if you want to introduce the concept of variables.
Okay. Well, I'm sure all of you have taken algebra before, so you kind of know what a variable is, right? So a variable is a thing where you can store a value. So in this case, the first variable we have is an integer. That's why we named it myInt. Int is for integer. So integers are just whole numbers, like 1, 2, 3, 4, like that. That's why we have a 3 up there. The second one is called a floating point number. And that's basically a decimal. And what's cool about Python is it's a what's called dynamically typed language. So in, let's say, C++ or Java, you would have to declare these variables like var myInt. And in Python, you don't need to do that. That's why Python is really easy as compared to other languages. So you can just put in a decimal and it will declare it as a floating point for you. Okay.
So yeah, there are a few types of variables. To recap what Samar said, you assign them a value, like right here. If you just put my int later in your code, when your code runs, the computer will treat every time it sees my int, it'll just put a 3 in there, right? And they stay that value until you change them. So yeah, an integer, a floating point number is actually based on scientific notation, but it's complicated and we won't get into that right now. Just know that it's a decimal. So there are a few types, there are a few other types of variables as well. So right here we have an int and a float. There's also a string. There we go, string. And what a string is think of, how many of you guys are in Algebra 2 or later? Probably most of you. Okay, so you guys know about sets, right? It's just a collection of numbers. Think about the ones with the curly braces. So that's just a set of numbers. You might have 1, 2, 3, 4, 5, 6, 7, 8. So a string is actually just an ordered set of characters. So in this string, the way the computer looks at this is it'll say, all right, we've got a T, and then in the second spot we've got an H, and then in the third spot we've got an E, and then space, and so on. So that's what a string is, and that's how the computer treats a string. Strings are a little bit different than the numerical variables in the way that they're treated. Yeah, that's that. Now,
one important thing about strings is you want to enclose them in quotations. That's very important. You can use single or double quotes. Personally, I like single quotes, but it doesn't matter. So if you don't have those quotes, see how it turns a different color? Now, when William does it in the Python terminal, it won't be colored because it's a very basic program. But in Atom, you'll be able to see the different colors. So in this case, yellow is a string. If you didn't have those quotes, it would all be gray. So that's how you do it.
question.
If you have double quotes in the string, do you take staples?
Yes, you do. So she asked an interesting question. So what if you've got like a quote within a quote? So like you're trying to put this paragraph in, and part of the paragraph is like a quote from another place. Say that you want to put a quotation like from here to here. Well, what's going to happen is that you're going to have a double quote here and here to start and end the quotation, right? And what the computer's going to see is it's going to see, well, you've got a quote here, and you've got a quote here. So your string is from here to here, and then your string stops. And then you're going to get all this random stuff here until your next quote, and your computer's going to see, oh, another quote, that's the start of a new string. That's going to come down to here. And you're going to get all this stuff in the middle, and it's going to throw out an error, and that's that. You don't want that to happen. So yeah, you have to escape quotes if you want to put them in a string, which is, I think in Python is as simple as putting a backslash before them. Okay, we'll go with that.
Problem.
Okay, so yeah, basically you just put a backslash before a quote, and that will, before any sort of, there are a few special characters that we'll see, mostly just quotes actually, double and single quotes. Also, I'll add you can use double or single quotes to enclose a string. If you've got, for example, something with a quote in it, instead of worrying about escaping those quotes and going to all that trouble, what you can do is put the string in single quotes, and then you can use double quotes inside of there, and it'll just recognize those as quotation marks. It won't see another string. So, excuse me. The next thing we're going to talk about is something called Boolean logic. It sounds really complicated, but it's actually like the easiest thing you've ever done. So, Boolean logic is based on a system where everything has state, and that state can either be on or off, or true or false, 0 or 1, right? So in this case, we've got two Boolean variables. One is set to true, and the other is set to false. It's pretty straightforward. That's really all there is to it. You can represent a lot of different things using this system. How many of you guys played Minecraft? All right. So if you've ever worked with redstone, that's actually based on Boolean logic. That's like the nerdiest thing you can do with Minecraft, but and that's saying a lot.
Made computers just
Oh, yeah.
using that.
Yeah,
It's
using Boolean logic and redstone, and that's how they do it. They use the Boolean logic, and yeah, so that's how they do that. And we'll talk more about that in just a minute. After we introduce the last kind of variable, which is called a list, and so on.
Okay. So as William said before, how strings you can think of as lists, same concept here. So you need square brackets, and each element in the list is separated by a comma. So in math, if you're familiar with sets, that might help. And here you can see we have 3 integers, a string, and then a boolean. So you can do that. You can mix up variables, and it doesn't really matter in Python.
Okay, so I had this all planned out, but then I left my adapter at home, so I can't plug my computer. We need to do some demonstrations of variables.
Well, if you want to just use an interpreter, because we can't access the command line.
I don't know how to do that.
So, well, just open that.
Can I type multiple line programs in here?
As long as you don't execute a command, which is fine.
Okay.
Just try.
Well, isn't it white space?
I think it's fine.
Okay.
It's been a while since I've used it.
Alright, so what we're gonna
well, yeah, we don't have command line.
so what we can try and do here, yeah, we're gonna improvise. So we're gonna see how this works. We're gonna see if we can. Programming is all about mistakes.
Sarah Yates, report to attendance. Sarah Yates, report to attendance.
How many of you guys can read that?
Cole Alder, report to attendance also.
I'm gonna see if I can make that bigger. Do you know how to make that bigger?
Try right-clicking on the window bar and see if there's settings for it. Try properties.
Properties. Good.
Oh,
First font. Here we go.
Wait, that just changed the window.
No, that.
Wait, go
that's
back to the previous
font size. There we go.
Yeah.
We got it. All right. Can you guys read that better now?
Yeah.
Okay, so we're at right where it says my bool and the cursor flashing. So we're gonna try and have this be true. All right. Now let's see if we can write. All right. So what do you guys think that's gonna do?
True.
Print true. See if it works. It does work. All right, we're in business. All right. So you guys understand that if I were to set my bool equal to like 1 and print my bool, it would print 1. And if I set it equal to a string and said print my bool, it would, even though the name is my bool, it would still print the string because that's what I told it it was. You guys get that? That's pretty straightforward. All right, so what we're going to talk about now is printing with lists because it's a little bit more complicated. So what you can do is you can declare a my list, and we'll just, for simplicity's sake, we'll just do that. And so what happens here is if I print my list, it prints out the whole list. Now sometimes that's good, sometimes that's what I want. But sometimes it's not what I want. What if I just want the third item in the list, the 3? Well, how do I do that? Well, now we get to a very important concept, the concept of how each of those values is stored in the list. So lists are 0 indexed. So how many of you guys are familiar with summation notation? Okay, so that analogy is not going to work then. So basically, the computer sees the 1 as the 0th object in the list, and it sees the 2 as the first object in the list, and it sees the 3 as the second object in the list, and so on. So that's called 0 indexing, and that's how just about every programming language treats lists, or sometimes in other languages they'll be called arrays. So if I want to print the third item, I'm going to type in my list, and then I'm going to have a little brace here, right? That sort of goes along with the braces on the actual list. And I'm going to print in 2. And that's going to be the third item because it's 0 indexed, right? So the way we think about it, the first item, second item, third item, but the way the computer thinks about it is 0, 1, 2. So we've got to go to 2. If we print my list 2, that's going to do what? Print 3. All right, print 3. That's good. Okay, so I think that's all I had for lists for now. Let me double check. Yeah. Let's do a little bit more, actually. So what would happen if I did print my list 18? What would happen?
Kind of blank set.
It would just sort of crash and burn. So, yeah, it doesn't like that. So that's a lot of words, and I'll be honest, I don't know what all of them mean, but
well,
it's a lot of
here's
words.
your most important thing: index
Yeah.
error, list index out of range.
Right. Yeah.
In Python, these error messages are really useful, so you can use them to kind of pinpoint where you've gone wrong. Because let's face it, we're programmers; we always make mistakes, right? That's why you need to learn how to read error messages and figure out what it's trying to tell you.
That's you hear the term debug a lot, and that's literally going through your code and looking for errors, and that's such a big deal because programmers make mistakes a lot, and that's just part of programming. Yes,
So looking for errors is when it tells you there's an error, or when you read it all back over looking for where you think
well,
it is?
generally the easiest way to debug is to actually run the program and see what happens. And in some programs, you can we'll get into debugging techniques later. We don't need to do that today. But no. Generally, just reading back over your entire code is not the easiest thing to do. Because if you're working as a professional software engineer, you might have 10,000 lines of code, and that you don't want to do that if you can avoid it. So we're going to do one more thing, and we're going to introduce sort of the general idea of a function. We're not going to go over exactly how to write your own functions today. We're just going to go over the idea of a function. So a function is just a bit of code or a keyword or something that when you call it, it does something. So we've already learned one function. Can anyone guess what that function is? Print. Yes. So print is a function. So what happens when you call the print function is that Python will print out the next line. All right. So the next function we're going to learn today is called append. And the way you call append is you call it on lists, and you type it like that, and then you put what you want to add to the end of the list. This is for if you want to add something to the end of the list. So say I wanted to add a 6 onto the end of this list. I'd type in mylist.append, and I'd put a 6 on there. All right, so that works. Now let's print. There we go. All right, so now there's a 6 on the end. So everybody understands that. It's pretty straightforward. All right, let's go back to PowerPoint. All right, so the next thing we're going to talk about are operators. So programming languages, especially Python, they can do math. Isn't that just what you wanted to hear? So we're going to talk about some operators. The first operator up there on the top left is a plus sign. Anyone guess what that might do? Adding things. There we go. So if I go back here and I type in my new variable equals 2 plus 3, and I type in print my new variable, any guesses? 5. Yeah, good job everybody. We can add. So I'm not going to bore you with going over subtraction and multiplication and division. I assume, well, I'm just going to tell you guys to trust me that those all work exactly how you expect them to. But the three on the bottom of that little top section there, those are ones we need to go over. So the first one is called a modulo operator or a modulus operator. If you're in discrete math, I know Mr. Webb briefly mentioned this, but he did. It uses something called modular arithmetic, and the way that's most of the time introduced is with a clock. It's actually also commonly called clock arithmetic. So basically, think about you've got a clock, right? And it's 10 o'clock right now, and you wonder what time it'll be in 5 hours. It's going to be 3 o'clock, right? Now, how did you get there? Because 10 plus 5 is not 3. The math doesn't work like that, unfortunately. Except that modular arithmetic does work like that. You're going to write you're going to take 10 plus 5, which is going to be 15, right? And then you're going to mod 12. Print that. Print 15 mod 12. So that should give me 3, right? Hopefully it'll give me 3. Gives me 3. That's good. So that's one way to think about it. Another way to think about it is remainders. It actually works exactly the same way. So if you divide 15 by 12, let's go back to 4th grade for a second. Pretend you don't know about decimals. 15 divided by 12 is 1 remainder 3, right? So that's just another way you can think about it. Alright, so then the next one here, that is an exponent. So you can do 3 squared. That gives you 9. Surprise, surprise. So the next one's a little bit more complicated. Again, like the modulo operator, it's probably not something you're familiar with. It's called floor divide. Now, in programming languages, a lot of times you'll come to a situation where you remember how we had the two different types of numbers? We had the integers and the floats. Now, a lot of times you'll come to a situation where you're dividing 2 integers, but your output type is going to be a float. Now that causes some issues because 2 integers should give you an integer. So one way to get around that is to use floor divide. And what that does is it takes whatever your result is and it rounds it down. So 5 divided by 2, anybody? 2.5. Good job. So if we round that down, that's going to get us to 2, and so this prints out 2. So that's useful in some applications. All right, so they're all the sort of arithmetical operators that we're going to talk about, and actually I think that's all of the arithmetical operators in Python. We're just talking about how they're applied to numbers today. We're not going to do too much with using them on strings because there are only a few of them that you can use on strings and they get complicated. So the next thing we're going to talk about is assignment operators. So Martha, do you want to talk about these? Do you have a couple in a while?
Sure. Okay. So I'm sure you can guess what the first one is. It's an equal sign, right? So that basically means something equals something. Now you use these. Okay. The next one is plus equals. So what that does is basically if you have a variable, so William had this one, my new var, right? 2 plus 3, 5. So let's say I wanted to.
That way we can make faster.
Okay. Now let's say I wanted to add 1 to A and make that B. So I want B equals A plus 1.
Yeah. Or do A equals A.
Right. Right. Yeah.
So the equal sign doesn't work exactly like it does in math. You can have something like A equals A plus 1 because the equal sign is an assignment. It's saying that A is A equals 1. It's not saying that they're strictly equivalent to. It's just saying all right, it's just saying, okay, the programmer here is telling me that the variable a is equal to a plus 1. So in this case, a.
Okay. Yeah. So in this case, it will take a, and so the program sees the a that you declared before, right? A equals 5. So now it's going to replace that value with a, which is 5 plus 1. So this should print out 6 once we print a again. So print it.
No, lowercase.
But
Yeah.
did I press caps lock?
Yes.
Okay.
And that's practice too.
See, name a is not defined. I did not define that variable. Oh yeah, Python is case sensitive, so a capital A is different from a lowercase a. And that's pretty important when you get to naming really long variables. If you want some capital letters, you need to keep track of all that.
Okay.
That should work.
A is 6. There we go.
So now, programmers are lazy. That's one thing you'll hear a lot. So we don't like to type out a equals a plus 1. That's a little redundant. So now let's redo this. A equals 5 again. And now let's say a plus equals 1. And what I did here is I did the same thing. A equals a plus 1. This is just a shorter way to write it. So now, if I print a, it should give me 6. And now the same, you can do the same thing with,
I don't have this written, but
oh,
go ahead.
okay.
Go
Plus
ahead.
plus,
Well, we'll go ahead. You can do the same thing with any of the other arithmetic
yeah, you
operators.
can do minus equals,
Times equals, divided equals. That's
okay.
all.
And then plus plus is just basically how I did a plus equals 1. You can become even lazier and just do a plus plus.
Well, no.
That's exactly.
Yeah, that's that one. So, no space. No space.
Yeah, print, or we could do print
Oh, yeah.
a plus plus. And then that should,
Oh.
It tells you the same thing.
Which part?
invalid.
Invalid.
Okay.
I wonder.
Or if we do b equals a plus plus, right?
Yeah, let's try that. Is it deprecated in Python?
Okay, well, let's
Alright.
forget about plus plus.
So,
It's been a while.
so one of the complications and shortcomings of Python is that there are a lot of different versions of Python that are still widely used.
Yeah,
So I was using, and you learned.
I learned 2.7, so in Python, is this 3.2?
I think this is
Yeah,
2.
so in 2.7, the good old days, you didn't need parentheses on a print function. So I could just do like print
Yeah.
space hello world in quotes and it would give me hello world. But that's not the case in this new version. And this new version is actually pretty old, but
Yeah. I like Python 2.7.
I love it too.
So there's no plus plus. I guess that's deprecated, which means that it's no longer a valid part of the language. So here's what we're gonna do.
So like any application, you'd say like Microsoft pushes updates to Microsoft Word every so often, right? So programming languages are constantly being updated with new features and stuff. And Python is one of those languages which is relatively recent. So it's going to be updated a lot and you're going to get a lot of new features and such.
Now that's not in any way dissuasion from learning the language. It's still a great language to know, and it's really one of
you should learn the language.
yeah. So you can keep up with it, and it's still one of the most widely used programming languages. So this last little bit down here, this group, these are Boolean operators. We're going to come back to Boolean now. So are there markers in here that would be easier? No, there aren't. Okay, that's fine. Let's get some space here. So, all right. So first, we're going to go over equals equals. So I said earlier that the single equal sign, that's not an equals, right? That's an assignment. It's different. It's not like in math. Now we're going to have something that's a little bit closer to math with these Boolean operators. These Boolean operators, essentially they're just operators where, like if you do a plus 1, that gave us 6, right? It's going to return a number. With these, it's going to return a Boolean, which means it's going to return either a true or a false. So if I do 4 equals 4, I need to print 4 4 equals 4. What is that? Which one is that going to give me? True or false? True. True. All right. So then the next one is a equals. No, it's not. It's a not equals. The exclamation point means not. It doesn't mean it's a really excited equals. Or like an upside down Spanish equals. So if I
Igualmente, I keep mine.
okay, right.
I got Spanish.
All right. So if I use that, what's that going to give me? False. Right. Okay. If I do